In the following question, the question reads that which alkane, when any one hydrogen atom is substituted by a chlorine, so you're trying to substitute a hydrogen by a chlorine atom, will not produce isomers. So I'm given 4 options, and I can substitute any one of the hydrogen atoms, and whatever that is formed, I need to figure out whether it's going to form isomers or not. And the first thing I need to do is I need to identify or define what an isomer is. So an isomer is the basically molecules having the same molecular formula but different structural formulas, which means that they have exactly the same number of atoms. So same molecular formula means that they have exactly the same number of atoms, but different structural formula means that their structures are going to be different, or their arrangement is going to be different. So I'm going to look at option A first. And the question states that any one of the hydrogens is substituted by a chlorine atom. So let me draw another molecule. So one of the hydrogens is going to be substituted by a chlorine atom. So let's substitute this hydrogen with chlorine. And let's keep all the other hydrogens. Now, if you look at this molecule over here that I've drawn, this is what he's talking about, that if any one of the chlorine is substituted, it's not going to form any isomers. So is there another way of rearranging this molecule? What if I try and put chlorine on the first carbon atom? If I put it on the first carbon atom, and I've substituted the hydrogen on the first carbon atom over here. Now, these two molecules, they might look different, but they are exactly the same. They're basically flipped versions of each other. If you pick this molecule up and you flip it around and you rotate it 180 degrees, then the chlorine would be attached to the left-hand carbon atom, and the hydrogens would be attached to the right-hand carbon atoms. So remember, by flipping or rotating or bending a molecule, you don't make isomers. When you're making isomers, you have to completely change the structures. You have to rearrange the bonds, and you have to rearrange the connectivity. So these two molecules are exactly the same, no matter which of the hydrogen is substituted, which means that whatever the substance that is formed, it's not going to form any isomers. So option A is going to be your correct option. Now I'm going to try and prove all the other options wrong as well. I'm going to show you that these option B is going to form isomers. One of the hydrogen is substituted, so let's remove the Cl hydrogen at the last carbon atom, and each carbon is making 4 bonds with 4 other hydrogen atoms. So this is my molecule. Now what I can do is I can make an isomer by rearranging the structure. This Cl is right now attached to the carbon atom at the end. What I can do is I can attach it to the carbon atom in the middle. So if I do that, so this Cl gets attached to the carbon in the middle, and the rest of the bonds are all hydrogen atoms. So these are all my hydrogen atoms attached. So you can clearly see that these two are isomers of each other. They're not the same molecule. They're not bent or rotated versions of each other. Over here, the Cl is bonded to the last carbon atom. Over here, the Cl is bonded to the carbon atom in the middle. So whatever hydrogen I substitute, I can still make an isomer of that particular molecule. So isomers are going to exist for when one of the Cl is substituted by one of the hydrogen is substituted by a Cl for option B. We can also try option C now. In option C, in exactly the same way, I can have the chlorine atom attached to the carbon atom at the end. All the other bonds being hydrogen bonds. The carbon is bonded to hydrogen. And I can make an isomer of this molecule. I can rearrange the structure. Instead of the Cl being attached to the carbon at the end, I can have the Cl attached to the carbon in the middle, or the third one. So these are all my hydrogen atoms. So this molecule also makes an isomer. Similarly, this option D is also going to make an isomer. So I'm going to quickly draw the 2 isomers. So here you can see the 2 isomers. Over here the Cl is bonded to the carbon in the middle, and over here the Cl is bonded to the carbon at the end. So this molecule, whichever hydrogen gets substituted by a chlorine atom, it's still going to form isomers. So only option 1A is the one that would not form any isomers. If Cl is attached to either of the carbon atoms, they're basically the same molecules. They're just flipped versions. You've just picked up the molecule and rotated it by 180 degrees. So it's basically the same molecule. The Cl is still attached to the carbon at the end. In both cases, they are exactly identical. They're not isomers.